Hello everyone. In this video, I'm going to show you how to use a custom written user script to automate the masking of features of interest in image matrix. In this demo image, we would like to analyze the conformation properties of the protein DNA complex. Now we have three proteins on this piece of DNA. What we want to do is we want to create cutouts for these three complexes and analyze, for example, a cutout like this, and analyze the mask inside this box. Traditionally, it's not possible to do with particle analysis because if you mask the protein and its DNA inside this cutout, it's going to mask the whole DNA. So essentially, it treats the whole DNA as one single particle. But we want ideally three cutouts. We want to analyze three particles, right? So we can't do this in the traditional particle analysis. Instead, what we did traditionally is to create these manual cutouts, right? We can do this in image matrix. For example, draw this box, and then we can say, let's send that to the region inspector, in which you can analyze this specific region individually. Or you can do this mask. You can say mask outside of this area. So what this does, I'm sorry, is to unmask outside of this area. So what this does is to unmask everywhere outside of this box and only keeps the mask inside this box. Let's do that. So now you have the mask inside the box. Now after that, we can analyze only the particle, the masked particle inside this box, right? So now we can right click this masked protein DNA complex. You can say click properties. And then it's going to show you the all these particle metrics of that specific protein DNA complex. So now we can repeat this process for all three protein DNA complexes. And so you can see that's a laborious process. And ideally, we want this to be automated. If we can just automate this process and let it mask all three proteins at once, and now we can just send them to the particle analyzer or particle classifier, then we don't have to inspect the individual properties one by one. We can have a table of them all at once, right? So now how to do that? So to do that, we need to use a technique called mask morphology. So essentially, we need to transform the mask and do all this custom stuff, right? Fancy. It can do very fancy stuff with mask morphology. You can click the mask tab. It's under morphology button here. So what I'm going to do next is I'm going to demo a script that I write to automate masking of the three protein DNA complexes. Just repeat this kind of mask for all three of them, okay, in one go. I'm going to demo that script, and after that, I'm going to discuss what kind of parameters in the script that the users need to input in order to facilitate their analysis of their specific research interest, right? So here I'm going to add this button to the quick access bar for easy access. And now I'm go back to my main tab. Let's see, I'm going to click the morphology button. I can click customize. So in this way, I want to add my own script to a list of morphology operations. Now within this morphology operation dialog box, you can create new profile for morphology operations. You can also load the existing one or customize one. The custom one allows you to write a new script. So here I'm just going to load the one that I already written. Let's click load. So in the latest image metrics program, there is a new folder called scripts. I already put my existing script in that folder. You can directly load them. Now the script that I use is called mask protein DNA. So I double click that. Now it loads the script file into this window. And I'm going to explain what it does, like the detailed parameters later on. But now let's just be good for now. Let's save the script as a profile. Let's call it mask protein DNA. Let's call this, set this as its profile name, and click save. Okay, so once I save this profile, you can find this in the profiles menu here. So okay, so let's demo that. Let's click the mask protein DNA, and this, what it does, it will mask all the 3 protein DNA complexes, right, all in once. Okay, let's do that. Now you see, it masks all the 3 protein DNA complex within a custom specified box. So in this way, we don't have to mask the whole DNA. We can we don't have to manually repeat this process to mask individual protein complex. It allows us to automate this process. All right, so let's examine what this script does. I have this open here, and I already commented most of the script, so you can read what it does. But here I just want to highlight the ones that users needs to take care of. That's the user input section. And so these are the parameters that we need to specify for our individual analysis, right? In the later part, the code is executed, so the user don't need to take care of them. So that's all the processing behind the screen, right? So the users only need to take care of these user input section. Now the first parameter that we need to take care of is the PD area average. So that's the average area of the protein DNA complex that we want to crop. Okay, so now how to do that? How to find that? So essentially what we're doing is we create a crop, right, surrounding this protein DNA complex, and we want to know the area of the mask inside this crop, right? That's to do that. So let's go back originally. Okay, this is where we started, right? So to do that, So you can imagine, so in order for the user to analyze these individual protein DNA complexes, they need to design a box around these complexes, right? And we want to know inside this box, what's the size of, what's the area, okay, of this protein DNA complex inside this box. So let's repeat the process, unmask outside of this area. So what we want to know is the area of this masked area, right? So to do that, you right-click this mask and click its properties, and we can find the area property in this window. And we need this area R, which is the real area in real unit. This is the area in pixel unit. This is in meters, okay, meters square. So we take note of that number. Right now it's like 7.3 e to the minus 16. And I'm going to copy that. And let's go back to here, okay. So I'm going to replace this number with the number I just copied. Okay, let's just place that. Okay, this is the number that we want. All right. So this is the area of the protein DNA complex, right? And you ideally want a area that's about the average that you want, because right now, just now we did a single protein DNA complex, but we will do this for every complexes. So you want to know what's the average area of these complexes. But it does not have to be precise. So we just use this area for now because we're going to design a range. So that's what the next parameter, next two parameters is design the range of this area. So what's the minimum area of this protein complex and what is the maximum area of the protein complex? And the minimum range I designed as like 0.5 of the average area, and the maximum I designed as 0.1, 0.8. So you can define that as you wish. You can play around with these parameters just to see how well it works. So essentially these two parameters is going to define the range of the area that we want to use, and they're going to be used for filtering purpose. And you can probably repeat this process for a few of these proteins and analyze that area and find the range of them, and then you can take the mean, the average as the average area. I think that's what I would do. So you can get a maximum range, right, and the minimum, and then you can take average of between the maximum and the minimum, right? Then take half of that and make that the average. So that's a better way to do that. So now we have the three parameters here defined. I mean, just for a demo, let's say it's 1.5 and see how well it works, right, for the maximum area. And then the next parameter, two parameters, is the size of the box. Okay, the box is the one that we use to crop the protein DNA complex. So I want to enter the size of this box, okay, in real unit, in meters, right? What's the width and its height, right? So I mean, I would simply use the same for the width and the height. As you can see, as you drag this box, the program gives its information on the status bar, right, on the bottom left. So you can see as I drag this box, you can read X, Y, width, height, and area on the status bar. And just read that area, read the width and the height, because it's about 30 pixels. That's not what we want. We want something real unit because this figure is in pixels. So we have to do this on the left figure. Let's drag the box again. Now it gives us the information in real unit in nanometers. So that's about 60, 52, 53, something like that. We can use a 50, okay? 50 nanometer. So let's specify that. Let's give it 50, okay? And then we need to find what's the area of the DNA, okay? This, yes, this is used to identify the DNA. That's for the back processing part, so we need to do that. So to do that, we mask the whole DNA again, and we right-click the DNA particle and click Properties. Masking the DNA is important because we want the proteins on the DNA. We don't want free proteins. We don't want to analyze free proteins. That's why it's used to basically identify whether the protein is in the DNA or not. So it's for the filtering process. That's the reason why we need the area of the DNA, because we need that to identify the DNA. So now we have the area of the DNA, I mean the properties of DNA open up here. So we have the area, which is 1.0 something, right? So so this one is just like we need a range. We just can get a cutoff of the area, so you can make something smaller. But DNA is really huge, so we don't need to worry too much of the exact number. Anything that's smaller than this little bit is okay. So we can use 1 to the e to the minus 14 as its area. So let's go back to our notes. The DNA here is 1, right? So we can just use 1.0, just 1 e to the minus 14. So anything smaller than the area that we just measured, right, would be fine. And the next parameter is the DNA mask threshold. This is the threshold we use to mask the DNA, and we just directly read from the screen, which is this number that we use to mask the DNA. Let's 2 points. Let's copy this number. Yeah, it's point. Let's just paste that number. It's like 0.27 nanometer. Okay. And next is we need the mask threshold of the protein. Right. So this one is to use the masked protein, but not masked DNA. So it's a mask threshold above the DNA. So it should mask the protein, but not the DNA. So we just need to mask the protein. That is used to identify the protein only. So that's the threshold we need to use. So to do that, we're just going to increase this threshold level until the DNAs are not masked, but all the proteins are masked. Now I have 4 of these, but we know this one is not the real protein, so we're going to increase the mask till that one is gone. Let's reduce that a little bit. Okay, there we go. So we have the 3 proteins masked in some form, not always. All we need to do is to have some kind of mask on these proteins, because we just need to know they're there to identify them, and then we're going to create a box around them. So that's not important to mask the whole protein. We just need some part of it to be masked. So now we can record this number, which is 1.69 something nanometer. Okay, so let's put that into our protein mask. Yes, you can use a smaller number than this one. So this single image, it's fine to use this number because we only have 3. But if you have a lot of proteins, DNA complex in your images, you would want to use a smaller number so that every of the proteins DNA complex are masked, right? So that's that number. You want the minimum number, not so you need to pick your number carefully. So right now, this number is fine because it already masked all three of our protein DNA complexes. All right, so once we have defined all this user input, this script is good to go. And if you don't want to, so this process was completely automatic. So I just, right now I can save this script, right? And if I want to mask the protein DNA complex, I just click this button, profile, and click mask protein DNA. It's going to it will mask the protein DNA complex for us. Let's click that. So that's this job. So this process is completely automatic. If you want to be a bit manual in how you determine the protein, so right now we just use 1.69 nanometers to identify our protein. So if you want this process to be manual, you want to manually identify your protein. So what you can do is you can uncomment this line. So let's say I'm going to uncomment this line. So we don't specify the protein mask threshold because we want to use our manual threshold. So they can do that if you want to manually mask the protein each time. So instead of using a flat value for the protein threshold, so you can do that for each image. So in that sense, you have to mask the protein each time, identify it, then we can run this script, right? So that's just one more step. If you are okay with this automatic process using this number only, which should work fine most of the case if the image is flat. I mean, if this threshold masks your protein complex in a universal way, then that's good. You don't have to do the manual process. Okay, manually find the threshold every time. Then you can just use this number and comment this line, and then you're good to go. So so after we masked the protein DNA complex, you can then perform particle analysis and send them to the particle analyzer, or perform particle correlation and send them to the particle classifier. So let's go ahead and do the particle classifier thing. Let's click the particle correlation. And we are going to use the particle analysis with default crop size as our particle source. So we have to perform the particle analysis first, and we pick up this option. So now essentially we have three masks, and then we can analyze three particles. We click analyze, and it gives us three particles. And you can already see the particles numbers and their traces along the DNA. Okay, so now I'm going to click the particle correlation, and then we choose the particle analysis with default crop size as our particle source. And then you're good to go. Yeah, just click OK. So after that is done, so after the correlation is performed, we can send them to the particle classifier to classify their conformations. Oh, I clicked the wrong thing. I need to click the particles. So there we go, and we have all three particles displayed here and aligned, and you can see that the first two particles, they resemble each other more closely than the third one. So yeah, then after this we can continue. If we have a lot of the complexes, we can continue this process with clustering analysis to automate this process. All right, so that's all for this video, showing you how to use user-defined script to automate the masking of individual protein DNA complexes.